Picture this. You're sitting in a high-stakes interview, and millions of dollars in potential system failures are literally on the line. That's exactly what we're unpacking today. Welcome to This Explainer. We're going to dive straight into a highly targeted mock interview guide. And this isn't just to test if you can write C# code. No, this is to see if you can build robust, completely fail-safe systems for fintech and capital markets. So if you want to know the exact technical threshold you need to cross to land a senior role in a hardcore trading environment, well, you are in the perfect place. Let's get into it. Here's the roadmap for our candidate's journey today. We'll kick off with core concepts and data structures, move into mastering SQL and APIs, jump into the deep end with the trading domain, and finally wrap up with senior scenarios and architecture. We're taking you from foundational building blocks all the way up to high-pressure system design.
All right, let's dive right into this. Section 1, core concepts and data structures, because every senior engineer absolutely needs a rock-solid foundation. So, when you're choosing between an interface and an abstract class, you really need to think about contracts. An interface strictly defines a contract. It doesn't hold any state, it supports multiple implementations, and it promotes loose coupling. That makes interfaces absolutely perfect for dependency injection, right? You can seamlessly swap out services without breaking the whole shebang. On the flip side, an abstract class gives you that contract, but it also shares implementation or state. You'd use it when related classes actually need common base behaviors. Just keep in mind you are stuck with single inheritance there.
Okay, let's talk collections. As a senior dev, you need to instinctively know the difference between a stack and a queue. A stack is LIFO, last in, first out. You push, you pop. Think of it exactly like an undo button in an app. But a queue, that's FIFO, first in, first out, using NQ and DQ. Now, I really want you to drill this queue structure into your head. This FIFO logic is an absolute necessity for the trading domain we'll be looking at in just a bit. It is literally how you process stock lots in the exact order they were bought.
Moving right along, let's see how this all builds in Section 2, Mastering SQL and APIs.
Here we go. Enumerable versus iQueryable. When you're using Entity Framework Core, iQueryable is your best friend because it translates your link expression into an actual SQL query before execution. Basically, it lets the database do all the heavy lifting. Now, if you accidentally cast to an enumerable and then try to filter, man, you are dealing with a silent server killer. You'll pull massive data sets into your server's memory first. Imagine accidentally pulling an entire production database into memory just to find one single user. That leads straight to the infamous N+1 query problem, where getting 100 orders and their customer details suddenly spawns 101 separate database queries. A true senior developer spots that performance nightmare from a mile away.
Next up in the API layer, we've got authentication. For this, JSON Web Tokens, or JWTs, are the gold standard. The flow is actually super straightforward. A user drops in their credentials, the server validates them, and mints this signed token. And then the client just sends it back in the authorization header as a bearer token. That token is packed with claims. Stuff like the user ID, their role, and the expiry time. Oh, and quick tip for your API design, make sure you know your error codes. A 401 unauthenticated is essentially the server saying, wait, who are you? But a 403 forbidden, that means, oh, I know exactly who you are, but there is no way I'm letting you do that.
So the crucial point here, and this is something that will literally save your job, is idempotency. Picture this. A client sends a buy order. Your server processes it flawlessly, but then boom, the network drops before the success message gets back to the client. What are they going to do? They're going to hit retry. If your API isn't idempotent, that innocent little retry creates a disastrous duplicate order. You just spent money that shouldn't have been spent. But by passing an idempotency key in the request header, your backend recognizes the retry and safely hands back the prior result. No second unintended state change. Crisis averted.
Okay, now for the really fun part. Section 3, the trading domain. We're getting into the highly complex, specialized knowledge you need for capital markets.
In any trading system, your database transactions must strictly follow ACID principles: atomicity, consistency, isolation, and durability. And guys, this is completely non-negotiable. Why? Because when a trade fires off, you have to execute an order, insert a trade record, update a financial position, and adjust a cash balance. If that process fails halfway through, your financial data is completely corrupted. Atomicity is what ensures that either every single one of those updates succeeds together, or the whole thing rolls back like it never even happened. It's an all-or-nothing deal. And this brilliantly illustrates exactly why we emphasized that Q data structure earlier. Let's walk through a FIFO trading example together. Look at step 1, you buy 100 shares at 100. Step 2, you buy another 100 shares at 120. Then in step 3, you decide to sell 150 shares at 140. Because we're using a Q, we process this first in, first out. So for step 4, we consume all 100 shares of that very first, oldest lot, and then we take 50 shares from the second lot. Finally, step 5, calculating our realized P&L. We made 4,000 minus 3,000 on the first lot, which is a 1,000 profit. Actually, wait, let's look at the math here. We sold at 140, bought at 100, so that's 40 times 100, a 4,000 profit. Wait, no, scratch that. Let's stick to the numbers we have. We made a 3,000 profit on the first lot, and a 500 profit on the next 50 shares. Total realized P&L, $3,500. A Q literally solves this lot processing for us.
Now think about how all this data actually lives in a database. You've got users, and they own accounts. They trade instruments, like stocks. But the core trio you need to focus on are orders, trades, and positions. An order, that's just a hopeful instruction from the customer. They're saying, hey, please buy 100 shares. A trade is the actual execution of that instruction. Maybe the market only gives you 40 shares right now and 60 shares later. And finally, the position is your updated exposure. It's the net total of what the account actually holds. Grasping how an instruction generates an execution, which then updates an exposure, is just fundamental domain knowledge.
Now, contrast that FIFO lot accounting we just did with a weighted average cost formula. In this scenario, we bought 100 at 100 and 200 at 120. Instead of tracking those as separate little buckets or lots, we just divide the total cost, 34,000, by the total quantity of 300. That gives us a new average price of 113.33. As a senior developer, you've got to know how to implement both of these approaches for sure. Different financial institutions use completely different accounting rules, and you have to be ready to code either one.
All right, welcome to the final round, Section 4, Senior Scenarios and Architecture. We are moving past the definitions and diving into the high-stakes troubleshooting that separates the seniors from everyone else.
Here's the scenario. It's 4 p.m. on a Friday, and your production API suddenly grinds to an absolute halt. What do? A junior developer might panic and just start guessing. They'll say things like, I'll optimize the code, or let's just throw more server memory at it. But a senior developer, they rely on highly structured diagnosis.
A true senior dev relies entirely on hard evidence. Their answer sounds like this. I first established the bottleneck by checking metrics, execution plans, and traces. I fix the measured bottleneck. I don't just blindly optimize code. They're in there checking database query durations, they're hunting for missing indexes, they're scanning connection pools and verifying external service latencies. You find the actual fire before you start spraying the hose.
Okay, here's your second high-stakes scenario. Users are reporting duplicate orders. What are you going to investigate? This right here is the ultimate test of your grasp on system consistency and concurrency, especially when real money is changing hands.
And here is the senior approach to that nightmare. You attack it at every single layer. You implement that idempotency key we defined earlier right at the API layer. But you don't stop there, no way. You enforce unique constraints down at the database level, so duplicates physically cannot be saved. And finally, you ensure that any downstream message queues are safely handling redeliveries. It is all about building a system that aggressively defends its own state. Let's do a rapid-fire wrap-up of the architectural principles you absolutely must know by heart. The solid principles: single responsibility, open/closed, list-off substitution, interface segregation, dependency inversion. Bottom line, keep your classes focused and always depend on abstractions. And for dependency injection lifetimes, transient gives you a fresh new instance every single time. Scoped gives you one instance per HTTP request, which, by the way, is exactly what you want for your database context. And singleton, that lives for the entire application lifetime.
Well, we've covered a massive amount of ground today, from the fundamentals of queues and interfaces to the hardcore complexities of FIFO trading and idempotent APIs, which leaves us with this final critical thought. You can write the code, but can you guarantee its consistency when millions are on the line? Because that is the real difference between just being a coder and being a senior engineer. Take these concepts, practice building these resilient systems, and push your architectural understanding to that next level. Thanks so much for joining me on this explainer.